Okay, so this is a talk called Automating AWS Integrations for System Initiative with Cloud Control API. Okay, this is an experience report more than anything else, and this is a piece of work that we started in January and have sort of been iterating over for the last couple of months. Anybody know the Cloud Control API? Great. Anybody know CloudFormation? All right, anybody who uses AWS may or may not have heard of CloudFormation. We'll talk about what the Cloud Control API is first, right? So, I'm an infrastructure engineer. I've been an infrastructure engineer for a long time. I worked on a small tool called Terraform for about 3 years, back when it was very small and became a big thing. Then I went and worked at another company called Pulumi. Now I'm on my third infrastructure startup in a row just because I love this stuff. This is why I wake up in the morning. It's my favorite thing to do, to go and build these types of tools. And for some reason, they made me the director of product because I have a lot of experience in this area. And they're like, maybe you can bring a perspective to it. And the reason I got in touch with speaking at user groups, like AWS user groups specifically, because I just joined the AWS Community Builders program. And it's super useful to go and talk to members of the community and learn about different things. So Mark's talk about Amazon Q, that's the first Amazon Q talk I saw in the wild. And that's why it was very interesting for me to see. I've seen every other AI tool talked about, but not Amazon Q. So it's actually always very cool to go and see different perspectives. If you want to talk to me afterwards, you don't want to talk here, shoot me a message somewhere. I'm around lots of places on the internet. I'm not going to sell you anything. It's not my job. Salespeople sell you stuff. I'm here just to talk about the actual tool itself. So System Initiative is kind of a new tool in the infrastructure as code ecosystem, okay? Most people will not have heard of it because it's incredibly small. It brings a new paradigm to infrastructure as code because it uses a digital twin model. Okay, a digital twin model is effectively, you have a simulation and you have the real world and you sync data between them. Okay, the best way to think about a digital twin model would be a Formula One racing car. Okay, you cannot make a live change to a Formula One racing car and just put it onto the track. People will die. Okay, now infrastructure as code, nobody's going to die. But at the same time, you could have a mission critical outage that causes your company a lot of money, or it causes you customer data loss, etc., etc. So we're trying to bring a new paradigm to the ecosystem where you actually stage your changes via simulations, and everything happens in a real model. Okay, so it is a real-time sync back and forward with whatever cloud you want. We primarily target AWS at this moment in time because it's the largest user base. Okay, whether Google Cloud users or Azure users believe it or not, AWS is a huge user base. We go after the user base, okay? But it can be programmed to any API or CLI, it doesn't really matter. Not the interesting part. Okay, so the challenge with System Initiative is that, or the challenge with infrastructure as code in general, is that keeping up to date with the cloud APIs or AWS APIs is incredibly painful. Okay, as a person who worked on both of these tools, I know this all too well. Okay, in fact, most of my GitHub contributions when I worked at these tools, I was 200-300 merges, 200-300 pull requests, GitHub issues, interacting with them per day, right? It was a huge amount of churn in the open source ecosystem. It is not sustainable. Okay, whether anybody tells you or tells you it is not sustainable. A team of 15 people at Terraform are never going to keep up with the demands of a team the size of AWS and a surface area the size of AWS. The Pulumi team have even less people working in an AWS provider, okay? So we have to look at different paradigms to be able to work together in this ecosystem, in this industry, okay? Now it just so happens that AWS released a new concept of being able to do this. Okay, in 2021, okay, they released a brand new API. Okay, and its promise was that this was going to be a unified API for creating, updating, and deleting AWS resources across all services. Okay, okay, disclaimer, okay, I'm from Northern Ireland. Swearing is in my vernacular. If it happens, I apologize. It just sort of falls out, okay? To say that you have a unified API across all resources is an incredibly ballsy move, okay? Especially the fact that some of the AWS resources are very old and are not as well maintained as some of the newer like services, okay? You look at something like S3, for example. S3 is an ancient API. It has all sorts of eventual consistency problems, the same as IAM, whereas you look at something like DynamoDB or API Gateway, and they're much better. They're much more architected to scale to like, you know, that more like feedback model. Now the key point here is it's 2021 that Amazon introduced this to solve the problem of resource management fragmentation. Okay, anybody know when Amazon, please don't answer. You will know. Anybody know when the first AWS service was released? 2002. Little later than that. Okay, like you're right, it's in the early 2000s, but yeah. And like you can imagine that it's taken them 14, 15 years to actually like be able to say, right, there's a fragmentation problem here. Different service providers, different teams do things in a different way. We got to do something about this, okay? Now, the architectural position here is that the Cloud Control API sits as a layer of abstraction across those APIs. It does not replace those APIs in any way, shape, or form. It is a layer of abstraction that sits across them that unifies how things work. Worst part of any AWS API, sorry, any AWS people watching, the worst part of any AWS API is tagging, right? It is the most inconsistent. Sometimes it's built into resources. Sometimes there's one name, sometimes there's the other name. It frustrates every person who uses AWS. Cloud Control actually brings a unified way of tagging. It's like, oh my God, like, you know, this is a nirvana. This is like the new way of doing stuff. So this is what they tried to give us. Now, its core capabilities is it gives you sort of 5 APIs out of the box, okay? It gives you create, it gives you get, it gives you update, delete, and list. But then it also allows you to do progress tracking, okay? Because not all operations in the cloud actually act in like correctly, and sometimes there is eventual consistency that you need to pull on. So it gives you the API to do that. And lastly, it does allow you to find the resource types, okay? So we call it, in system initiative world, we call this discovery. Okay, now every infrastructure as code tool has promised you the ability to bring your infrastructure into that tool or port from one tool to another. We all lied, okay? I used to give talks about this for each of these tools, and I used to tell you, you can import your stuff to Pulumi, import your stuff to Terraform, and the world is a brilliant place. I lied, and I'm sorry, okay? I didn't actually specifically lie, I just didn't realize that the promise that I was selling you was not the real promise, okay? And now again, I'm not saying System Initiative is in any way, shape, or form better. I'm bringing a different perspective that I've learned about what these tools have given us. So, you know, it looks at it in a different sort of way here. Now, it's really funny DynamoDB is your favorite service. That is literally my example. It's like, actually, I was like sitting there going, this is going to be really, he's going to love this. So actually to create, this is using the AWS CLI, okay? You can translate this into an SDK and it looks exactly the same, or you can do whatever you want, okay? But effectively, it always looks in this way. You give it like you call the Cloud Control CLI or the API, and you basically say, I want this type, and here is the document that I pass it. Now, that document is an incredibly well-formed document. That document is a CloudFormation specification. Okay? Now, CloudFormation has been in AWS for a long, long time, and it is used and littered throughout our ecosystem. The fact that they have created this API spec on top of all of the services, but use the CloudFormation specification is incredibly good, because it is well-formed and it is very well-opinioned. Now, the fact that it does it, it means in this case, what this does is this doesn't just give you a progress and it just like waits and waits and waits. It actually returns you a token, and then you take that token and then you go back to AWS and you say, give me the status. Are you done yet? Nah. Give me the status. Are you done yet? Nah. Give me the... So you can pull in whatever way you want. So it's a very nicely architected system to be able to do this. Like, what are the benefits here? One, it's consistency. Like, same pattern across all of your services. Okay. 2, reduced cognitive load. I mean, the fact that there are, I don't know, 75 AWS services at this moment in time, something like that, maybe even more, and each of them do things in a different way. and it all depends on which developer implemented them or which developer moved between different teams. Not because they're doing anything wrong, it's because they're able to deliver fast and do the same things in a different team. Like, this API is a reduced cognitive load. You learn that API, boom, it's done. You know exactly what's happening under the hood. Now, AWS, I've been on calls with AWS about this, okay? And they say internally, all of their new services will be built in this manner, okay? They promise that that is the case, and they have a long list of things that they've been migrating across the years. I first came across Cloud Control API 4 years ago now, when I worked at Pulumi, when we started implementing it there. And as you can imagine, at the start, there was very little coverage for it, but it has grown in a huge way. Okay, so this is their new way of building stuff. And by default, because you have CloudFormation, by default, you get Cloud Control API by default. So there's that ability because of the way that they've built it. It's correct. Absolutely correct. Now, if something is not supported in CloudFormation, it's one of two things. One, it's an incredibly old service, okay, that was created probably before or has not been migrated to it. Or two, there is a specific reason why that is the case. Now, there were all sorts of nerds in the community who used to try and race CloudFormation to release things in the wild when they first came out, because CloudFormation was an afterthought rather than the forethought about how AWS built services. My favorite thing I ever did, and looking back on it, I'm the world's biggest geek. I sat waiting at an AWS reInvent announcement for a NAT gateway. I knew it was coming because I was on an MVP program. And I was sitting there waiting to release the Terraform provider for the NAT gateway, and I beat the CloudFormation API by 3 days. Okay, because I had a beta release of their SDK, but the SDK wasn't ported to CloudFormation. Okay, so this is why it's all changed now, okay? It's literally it's all gone in its head where it goes to CloudFormation first and then everything else. And actually, internally, the CloudFormation engine is going to start using Cloud Control under the hood. Okay, that is the new way that they're starting to build stuff. So, and then lastly, of course, it's program and agnostic. It's a REST API. Talk to it from anything. And lastly, it's automation friendly. It's declarative. Okay, it enables you to automate stuff. It's very well put together. So it's going to be awesome, right? Nope. No. No. So I'm going to show you what we did. And I'm actually going to show you the code. Everything I'm showing here is open source, so you can go and you can have a look, okay, at our code that does this. Wow, this is going to be, yeah. No. Zoom in. All right, so we're going to look for Clover, and we're going to go into the CLI for Clover. Okay, don't know why we called it Clover. I think it's Clever Cloud, something like that. I don't know. So basically, what we do is every night we download the CloudFormation specifications. Okay, we actually do it multiple times per day. Okay, AWS release a JSON or a zip package of all of the CloudFormation specifications for every single service that there is. Okay, you can download it, you can do whatever you want with it, and it's awesome. Okay, we take that and then we break that up. We chop that up into each of the different services, and then we generate our own specification internally. And what that actually looks like for us is in our pipeline steps, we do the following. Spec pipeline. Yeah, this one. Where are you? Commands. No? Yeah, generate SI specs. Okay, this is all TypeScript, so if you don't understand the JavaScript or the TypeScript, doesn't matter. I'm going to explain the premise. The premise is just totally fine. Okay, so the first thing we do is we download the JSON spec files. We chop those JSON spec files up and we create our package spec, which is just a base set of properties. And then we start to enhance it. The first thing we do, AWS, believe it or not, have bad doc links in their CloudFormation specifications. So we check each of the links to make sure that they're actually correct. And if they're not correct, we remove them, because worst thing we could do as a vendor would be to surface a link that takes somebody to 404. terrible experience. We just remove that, okay? Secondly, we start to take the CloudFormation specification, which has text in it, okay, which has descriptions of assets, and I will actually show you one in a second, okay, and we run that through an AI generator. Okay, because in System Initiative you have like this UI that allows you to be able to select things from like control panels, and we like to like make that as nice an operation as possible. So for example, with an S3 bucket, an ACL for an S3 bucket can be public read, read-write, private, or protected, right? These types of enums, that's not ever exposed anywhere except in a block of text. Okay, so we take that block of text and we push that through an AI generator, and it gives us back our enum spec depending on what we want. We store that, okay? We do not want to be pushing every asset change through an AI generator. It would bankrupt our little startup. So we actually only push it through when that document has changed, okay? We can detect if that individual document has changed and we push it through. From there, we start to generate our output sockets from our props, and we add our common actions, and we add our and if I show you like one of the actions, it's a cloud control action, okay? I showed you what it was like a second ago to create a document, and what we do is we build this code string, and then we JSON parse the code string, we set the type name, we set the desired state, and we just call the AWS CLI. Like, we're not calling Terraform, we're not using Terraform's engine, we're not using Pulumi's engine, we're actually talking directly to the cloud itself, which means that we are one-to-one with what is going on to AWS, which is brilliant because when changes in AWS happen, we can ingest those. Users themselves can ingest them, not just us, and they can actually use the thing. So they can take exactly what System Initiative runs, and they can run that themselves, and they will get exactly the same result every time. So it's like perfect for that type of thing. But the interesting thing that what we want to do, come on, there we go. Like, sometimes not everything that comes back from the Cloud Control API is right, okay? And I told you it's gonna work, it's not gonna work, and we're gonna talk about why it's not gonna work. Okay, so let me go back to presentation. Come on, I don't know which side this is. Oh, there it is, yeah. Presenter. All right, so for us, it's a case of, we built this CLI tool, we download these specifications, we chop them up, we generate our packages out the back of it, and the world is great. Attempt 1 was incredibly interesting for us. Okay, they promised us one thing. Those cheeky little people, they lied to us. It wasn't unified. Not all services covered everything, and they didn't tell us that that was the case. Or rather, the CloudFormation specifications didn't tell us that that was the case. Now, if you go to that little page on the AWS documentation and you search for cloud control supported types, it will give you a list that looks like that. And that page scrolls and scrolls and scrolls and scrolls and scrolls. Now, notice that there are missing cells. The fact that there are missing cells means that when we generated our assets in System Initiative and users started creating them and the world looked fantastic and they hit deploy, the Cloud Control API was like, no, can't do that. This is not supported. Terrible. It was like the worst thing ever. It was like, oh, what do we do? All right, so there were key services here that were not supported. Okay, root 53 record set. You can't create root 53 record sets using the Cloud Control API. That means you can't create a DNS entry. Pretty basic use case. Second style of use case, being able to create a certificate manager certificate. Okay? Next type, Elasticache. You can't create an Elasticache cluster using Cloud Control API. So we were like, oh, right, that's pretty crazy. What the hell do we do? We had 1,800 assets. An asset in System Initiative is a service. So think of a certificate, a record, an EC2 instance, a DynamoDB table. We were able to generate 1,800 using the Cloud Control API. We cannot use that API because they're not all created equally. And it felt like now it's the equivalent of like a tariff, right? Like we were like hit with like you gotta pay for this type of shit. But attempt 2 is a little better. So what we did is we went back to the drawing board and we were like, you know what we're going to do? We're going to determine breaks my heart to say it, we took that HTML document and we parsed it. I'm not joking. A part of me died when we did that. Okay, but we took that HTML document and we parsed it, and anywhere where there was an empty cell or it wasn't included there, we just skipped it. Okay, so if the CloudFormation specification, the actual JSON file from AWS, wasn't included in that HTML document, which is very well updated, by the way, updated every day, we just went, nah, just don't worry about that asset. We went from 1,800 assets to about 1,300 assets in a couple of hours, right? Now, to lose 500 assets was not a great experience for our users because we promised this 100% coverage of the AWS surface area that CloudFormation gave us, and that wasn't true. Absolutely not true. And it wasn't AWS's fault, please don't take that it was, it's just the case of how they're actually building it. And now we've talked to AWS about this, and they said, look at the services that are included. And the services that are included are more troublesome services. For example, there are IAM services that are not included. There are Route 53 services that are not included. Things that have been architected like way before they put together some of the new stuff, and it's more difficult for them to backport them to this new way. They're not saying that they will not do it. They have a guarantee that they will cover all of it, but some things are higher priority than others, and they will get to backport in. So they're kind of in the long tail, is the way they told us, the way they sold us on it. So we needed to go back and have a think about this again. And we started this project in January the 4th. Okay, we came back from Christmas vacation break, and we sat down as a leadership team, and we were like, right, we got to accelerate our AWS coverage. Okay, we used to manually create the assets ourselves. I couldn't create assets fast enough. I really couldn't. We had people popping up on our Discord. We had people popping up on our customer support channel saying, I need access for this, can you give it? And we used to like bash the hell. We tried to use generative AI to do it, and it was rubbish. It was not because of anything else, but exactly because of what Mark said. You got a different temperature each time. And sometimes it just made shit up. It literally just decided that that part of the AWS API looks like it should be there. We're going to put it in, and it was fucking not in. Like, that's just what happened, right? So we needed to go back and have a look. And we've used all sorts of models to do it. We used Anthropic, we used OpenAI, we used the different like versions of within Claude itself. Like, we were able to do anything. But I was kind of delighted with what we had achieved until we had this big realization of something was wrong. Okay? Now, we got to the point of, why are you not doing this? We got to the point where life was doing okay. Okay, we were able to get some of the pieces that we needed and some of the pieces that we weren't. And we went back to the drawing board and we started thinking, hey, let's have a look at what the CloudFormation specification is. Okay, now we noticed a similarity on the top file, that JSON document, is the end. It is the bottom of a CloudFormation specification. Okay, and we started putting together some investigation of like, hey, let's look at it and let's see if we can see any deterministic items in there that can help us identify it. Because it was really good at telling us if things were create only. Now what I mean by that is if you create a VPC and you give it a CIDR block, you can't just change the CIDR block of a VPC, right? You have to destroy your VPC and create a new one, or you attach a secondary CIDR block and do it that way. So there are some things that are create only operations, and it was fantastic at telling them this. And one of our engineers noticed this little section at the bottom going handlers, and we were like, hold on a minute. What's this? What's this little nugget of gold at the bottom? And we started looking at it and we went like, let's go and have a look at the document. Oh, those three things map to the three things that are supported in the Cloud Control API. So there's a pattern. If there was a handler section at the bottom of the JSON file, the CloudFormation specification, it was supported in the Cloud Control API. And then even internally, the different operations within the handler section mapped to the different parts of the API that were suggested. Fucking hallelujah. I mean hallelujah, because this was like a massive look at what we were able to do. but we still had this missing segment of assets that were not supported by CloudFormation, or excuse me, by the Cloud Control API. What were we going to do? Now, we had the CloudFormation specification. And whether you like it or not, CloudFormation is pretty good at what it does. Right? Love it or loathe it, like, I'm not a big fan. But at the same time, it's actually pretty good at what it does. It just, how it does it internally, it's a black box that you just will never see into, and you just have to like let them handle it. It's like what happens in a Terraform configuration, right? Unless you look at the internals of what a Terraform DAG does, you'll never understand that. You'll just see, oh, it rolls out in a specific order. CloudFormation is the same thing, but we were like, we could delegate to CloudFormation here anything that is not supported by the Cloud Control API. And we were like, actually, that's not an awful experience. It'll work. It'll allow people to bring items onto their diagram. They can connect them and they can pass the data. So every asset that doesn't support Cloud Control, we added a little output socket, which is a CloudFormation resource. We built a CloudFormation JSON spec file, and a well-formed document, and we passed that into a CloudFormation template and then onto a CloudFormation stack. Okay. Now, there is a potential issue here, is that you only get 2,000 CloudFormation stacks per AWS account, and you can very quickly run out of them. But there's ways around that, of course. Like, you know, you wouldn't always do a one-to-one mapping into a CloudFormation stack. You could put multiple templates in, and the stack set will actually be able to bring them together. So it was a unique way. But there are still issues. There are. Okay. CloudFormation doesn't natively support import or discovery of assets. Okay. What I mean by that is, if you're a Terraform user and you have created something in CloudFormation, you can take that ID and you can import it into your Terraform file. If something was created in the AWS console, you can't import that into CloudFormation. Okay, so CloudFormation, you can't sort of backfill into it. So therefore, there was a major part of our system that was missing. We promised import, and we promised discovery. Okay, second thing, I don't know the reason why this is. The get resource request in Cloud Control API sometimes, and I mean sometimes it's sporadic, doesn't return all of the data that you actually need. Okay, so if you know EC2 launch templates, and you ask for you pass in the launch template ID, and you say, give me the resource back, all it shows you is the ID and the version. And then it's like, make another call to get the other pieces of information. I was like, well, that's no fucking good, right? Like, why not just give me all of the data I need and let me filter it out? It's like, no, you can make multiple calls and just like it. That's just the way it works. So, you know, that was a problem. So we needed to be able to supplement what we were doing with overrides. And what we actually did is we were actually able to build these overrides. Oh, wait. All right. So we built this asset-specific overrides file. And this asset-specific overrides file allowed us to control the types of information that we needed to do. So within System Initiative, for example, sometimes we need specific types. Sometimes we need specific data available, and we supplement. A perfect example here, okay, is an EC2 instance. In the AWS console, if you create an EC2 instance, you can either give it base64 encoded user data, or you can give it plain text user data, and it will take care of it under the hood because it is a layer of abstraction. The API does not like that. No, the API does not like that. So what we had to do is we had to override the attribute function, which takes, so everything in System Initiative is a function, okay? It is a hypergraph of functions where you connect sockets together and data runs in each function the whole way down. So when you connect two components together, it takes the function output of one component and it passes it into a function in the other component and it computes that. Okay, now if you're passing raw strings, it just takes the string and it passes it on, but we needed to do something with that string. I wrote the worst TypeScript I've ever written in my life. I'm not going to show you it. I wrote it. I have to take responsibility for it. You can even see that my name is there 2 weeks ago, and I will take responsibility for it. But basically what it does is it takes that user data, it tries the base 64 to code it. If it decodes, then we know it's base 64. If it doesn't, we know it's plain text. And then we actually re-base 64 and pass it on. I told you, it's not nice. But it works. It's incredibly effective at what it does because those functions are really fast. Right? So we were able to write that like override for that specific function. We were able to set like the user data to be a code editor that people can pass it in. And we were able to do other pieces of information. So another one is like infrastructure as code tools are declarative. Okay, so you tell it, give me 2 instances, and it will handle giving you 2 instances. You can't say, give me 2 instances, and then reboot it and take a snapshot and then connect it to this. You have to usually delegate to another tool like Ansible or Chef or something that does that. System Initiative is not a declarative tool, so it's basically a workflow engine. So you can say, create this instance, then reboot it 15 times, and then destroy it, just because you can, and it will actually do it because it's just functions and it just runs through. So what we started doing is we started being able to add other functions in. We supplemented the behavior of reboot, start, stop, refresh instances and auto scale and groups, all these different types of things. Okay, so there's like a whole like heap of information that we were able to actually put in there and override it. So Cloud Control API wasn't always very good at giving us all of the data it needed, which was a real problem for us. But the fact that we were able to get around it and the fact that we were able to like do these different pieces was pretty cool. Now we built a pipeline, and the fact that we built a pipeline is the power of like Cloud Control API. It's declarative. We know we're going to get exactly the same things every night. So there you go. That's last night's change, 19 hours ago. Yeah, just like before I started heading towards the airport to come here. And it actually told us here are the 4 new pieces of information it brought in. So it had a change to Lexbot, event connection, API, blah, blah, blah. And then we could say, you know what, maybe we want to see what the diff is on each of them. So it breaks it down. There is a new socket called ARN for policy. So there was a new addition to the connection stuff. We picked up, just before my demo last week, it was really cool. 6 hours before I did the demo, we had our cron run, and it picked up 3 new services, which is the EC2 VPC route servers that was launched at the start of April. And I was able to go to the Terraform repo and see that there was a request saying, please, can we have support for them? And I was like, I didn't even know it was a thing, but we have support for it. It was really cool. And it was not because we did anything, it's just because of the fact that the Cloud Control API gave us that information. I'm going to run this cron every single hour of the day. It costs me 0 to run. GitHub runs it. It computes the data for me and it passes it back. I could run it every minute if I really wanted to. So for us, it was like actually pretty cool here. The fact that we have a demo, the fact that we have that pipeline means that we can start to be able to do lots of different things. So every time a pull request is opened, even by ourselves, okay, this is the important thing. We do exactly the same thing. If I have a look at like some of my own pull requests here, I'll just do one because it's boring. Come on. There you go. So fixing the ability to connect WAF or Web ACL v2 to an ALB. Okay. Now there are semantics within System Initiative that basically said ARNs can connect to ARNs, but there is a Web ACL connection or Web ACL association that you have to do with the AWS CLI or the CloudFormation API that calls it a resource ID, not an ARN for some reason. So our system wasn't clever enough to realize a resource ID is an ARN. But it's not an ARN because sometimes it's an instance ID and sometimes it's a load balancer name. And so we were able to add some semantics, but straight away, when I made that change, it was actually able to see, look, there's one socket, no other changes to our assets were created. So there's no risk in anything else for our customers at this moment in time. And then based on that, we could say, let's see that change. And all it did was just added a connection annotation that allowed these 2 pieces of information to go together. Okay, this pipeline is gold dust for us. This pipeline will not just work for AWS, we will do exactly the same for Azure. I don't even know if Google Cloud has a good API. It has magic modules, it has something. Nobody uses it. I'm glad you said that, because if I did, I would, again, but I kind of agree. But yeah, so like this was incredible for us. This was really, really incredible for us, and this allowed us to be able to do a lot of different things. Now, Last thing, and then I promise I'm going to shut up because I could talk about this forever. Like, this is so much fun to build. Like for us, we tried to do this with, I said we tried to do this with Gen AI. We wrote these awful prompts. I really mean, like, I can actually show you one of the, I actually just, when I was sitting out there earlier, I was deleting the prompts that we did with Gen AI, and I can actually show you the fact that I deleted it. Come on, where is my fucking mouse cursor? Oh, there we go, right? So you can see, look, removing something called asset sprayer because it was just spraying crap. So we literally called it asset sprayer. And the prompts were, let me show you an example of a prompt. Back to cargo. There you go. Here is the prompt for generating our asset. You are an expert cloud engineer who understands the AWS API and say, look at the shit that you have to feed this. Like, I mean, and like, honestly, like now I could go into a rant. Like I literally could go into a rant, not because of OpenAI. It's like, you need to provide, like we were having to give it the context about our system, but also like giving it the rest of the context in your, of the workspace that the user was in. That's why I asked earlier, is like, it generated the code, why did it not know that the context was already there? This is the reason why. We've been through this loop and we've had this nightmare and it was not a fun thing to do. But look, it's still going. It's still going. We even had to feed it like types. Still going. That's one type of function.
Is there a limit to the size of that prompt?
I mean, maybe. We split it up into different things. So we had different agents doing different like function types because of the fact that we were having to feed it so much information. And then we actually split down each agent to be able to do different things, right? So we got into a farm of agents to be able to do this type of thing. And it was hard work. It was literally hard work. And this is what I was saying. Sometimes it just made shit up. Like it literally was just like, that looks right. And it wasn't right. But it was so confident. And you know when you're in ChatGPT and it's like, I can't give you that code. And you're like, are you sure? It's like, all right, then I'll give you that code. Right? That's what it was doing. It was literally, it's like that. It's like, does this really exist? No, actually it doesn't. But it looks kind of cool. So I'm going to give you it anyway. So it was really a case of Gen AI for us was not fantastic. Now we're building a different way to be able to do this because funnily enough, if you feed CloudFormation or ask Gen AI to give you CloudFormation specification, it's pretty damn good at it. And it so happens because the Cloud Control API uses CloudFormation, so we're starting to build our own like internal chatbot for our system that you can start to say, you know, can you teach me the CloudFormation that would allow me to do X? And it will pop you out the CloudFormation, and then you're like, right, now can you format that as a system initiative asset? And it'll pop out the 4 assets that need to be able to do it. Because it's totally within the control that it's so scoped to CloudFormation. Now next, we have that pipeline. Pipeline does this well. Last conclusion, okay, I have 2 minutes left, okay? The information that's there. I'm sure if we created a smarter pipeline, we would get much closer to the truth. But the amount of movement that we have to do in overrides is relatively small, so the investment we had to make there is actually relatively small. We finished this entire project in 1 month. Okay, I was an engineer manager at Pulumi for 4 years, and my team generate our schema. Our schemas are incredibly fixed, okay? And the fact that they're incredibly fixed and the fact that they're so specific against the CloudFormation spec means we don't need to generate another API on top. It is a one-to-one mapping. Terraform and Pulumi, they use an API and they generate another API on top of that. And then they have this triangle dependencies of AWS versions against Terraform versions against Terraform provider AWS versions. And you have this just nightmare of conflict. And it's a hard problem to solve. It really is. And then lastly, the missing and discovery and import for some assets is painful, and we are starting to have a workaround for that. Okay, we are investigating that we can write our own manual overrides in the same way as I showed you an override for the horrible base64 function, that we can do a similar thing for import and discovery. And then lastly, the fact that we can override any of our assets to skip the CloudFormation, the Cloud Control API directly, we can go to the AWS CLI if we want. And if you really wanted, you could override it all and you could just say shell out to Terraform and here's like a load, like generate me the HCL and it will go and do that as well. It doesn't matter. It literally doesn't matter. So for us, this is like an incredible usage of this API. Like without AWS, we wouldn't have been anywhere successful here. They didn't do anything. They actually want us to give the GenAI output of the documentation for the enum so that they can push that back into the CloudFormation specs. They thought that that was a really cool usage. What the team who we talked to said is they're going to run it through Q to see if they get the same output because they're very interested to see the temperature check on that and see how it goes. But we'll see. We'll see how that works out. So thank you all so much. This is like an experience report, as I said. It's something that most of you don't know about because it's Cloud Control API. If you use AWS on a regular basis, check it out. It is actually incredibly useful what you can do with it and the types of information you can do with it and how it links into tools like Q and Claude and OpenAI. You get such good results every time. It is so worth your time investing. Thanks so much.